So welcome to the part 5 of module 4. In this session we'll discuss how we can iterate through the arrays using the typical for loop, and we'll also go through the function apply along axis. So suppose we want to iterate through an array. So we have learned so far how we can create an array. So if suppose I want to iterate or access the elements of the array, the typical way is to use the for loop. So here this is the this is a one-dimensional array that we have created using the arrange function, and in order to iterate through this array, it's a simple for loop. Take any variable, let's say I, in a, followed by a colon, and then give print I. So this will print all the elements in an array. So suppose I want to iterate element by element, then the difference between this and this is, instead of saying a, use a method called as flat. So a.flat. So when you say a.flat, it actually accesses every element or iterates through the array element by element. So this is another example. We have created a two-dimensional array, and in order to iterate through the two-dimensional array, again it will, if you use this method similar to what we used in one-dimensional, it will scan the rows in the first loop and it will scan the columns in the second loop. So you just have to write for row in A and then print the row. So it will start printing the rows. Okay, so let's see this on the terminal. So let's first create an array. So we already have a unidirectional array over here. So in order to iterate through this array, for I in A, which is the name of the array. Now since we are still in the for loop, you see this 3 dots. Okay, so now before I give print, ensure that you have the indentation. In Python, indentation is very important because we do not use any braces or parentheses. So just give a tab, a single tab, and then give the statement. So print I. So now you can see that all the elements are displayed. Now the same thing, now let's replace it with the dot flat command. So this will, now what it will do is it will iterate element by element. The same function we have just used. Instead of just saying A, now I'm going to do a.flat. The difference is it will now iterate through the array element by element. See, here we cannot see much of a difference because it's a unidimensional array. We can see the effect of dot flat when we use a multidimensional, which we will see. So let's now say I have created a multidimensional array called as A. So how do you loop through this? So similar to what we have done in unidirectional, but the difference is when it's iterating through a two-dimensional or multidimensional array, it will scan the rows and then it will scan the column. So let's say if I take the element as for j in capital A colon, and then just give print of j. So you can see that all the elements in the two-dimensional array are printed. So now suppose I use dot flat over here. The difference is it will now iterate for every element in the array. So we'll just repeat the same statement. See the difference, right? So when I said dot flat, you can see that it has iterated for every element. For every loop it will iterate, right? And it will print that statement. So basically it is iterating here 9 times. But what has happened in the previous method is when I don't use dot flat, it will first scan the rows and then it will scan the column. So that's why it's printed this way. So this is for iteration of an array using for loop. Now there is a very important function for iteration, which we call it as apply underscore along underscore axis function. Now when do we use this function? This is a function which is there in Numpy. We can use this function when we want to use or launch an aggregate function or a universal function or maybe your own function for iteration through the arrays. Okay, so if you want to launch an aggregate function that returns a value which is calculated for every single column or on every single row, then Numpy will manage this iteration using this apply along axis function. So what is the aggregate function, universal function we have seen in the last session? To quickly revise, Aggregate function is a special function in NumPy. Now this will like sum, minimum, maximum, or finding the mean. So if you, these are all come under aggregate functions. Why is it called aggregators? Because it is performing this operation on the set of values of this array. So when it is calculating sum, it is considering all the elements in the array. When it is finding minimum, it is going to consider all the set of values in the array and take the minimum. So these are all aggregate functions. And when it comes to universal functions are operating element by element. It will operate on element by element in the array. So for example, square root or logarithm or sinusoidal. So what does square root do? It will calculate the square root for every element in the array. So that's why this is a universal function. Logarithm, it will calculate logarithm of 1 and display. It will calculate logarithm of 2 and put it in the array. It will calculate logarithm of 3 and put it in the array. So that's why these are called as universal functions. So if we want to use such functions during the iteration of an array, then the best way is to use the apply along axis function. Because what apply along axis function will do is, it will take 3 arguments. The first argument, there we specify which function we want to use. Do you want to use the aggregate function or any universal function, or do you want to use your own function which you have written? So that we have to specify. Name of that function is the first argument. The second argument is the axis. So if it can take 2 values, either it can take 0 or 1. If I give the axis value as 0, that means the iteration is evaluated for column by column. Okay, so if I want to do the iteration column by column, give the axis as 0. But if I want to do the iteration or evaluate the elements row by row, then give the axis as 1. And the third element is the array. So what is that array that you are using now to do this iteration? That you specify in the third argument, where you have to say ARR is equal to the name of the array that we have defined. Okay, now see this example. Here first let's define an array. We have defined a 3-dimensional 3x3 array. So upon that I am using the aggregate function mean. I am saying 0, so that means the mean is being calculated column wise. Otherwise the mean is being calculated. If I say 1, the mean is calculated row wise. Let's see this in the example in the terminal. See, this is our, let's first have take a 3-dimensional matrix. So upon this matrix I am going to now call the apply along axis function. Now remember, this apply along axis function is part of NumPy. That's why you have to say np dot apply along axis. Okay, so type here np dot apply underscore along underscore axis. Now it can take 3 arguments. The first argument is the function that you want to do. Suppose I want to do mean. Now again, mean is a function which is under NumPy. So say np dot mean, comma, which axis? Suppose I want to do it column wise. I will make axis is equal to 0, comma, what's the array? So ARR is equal to capital A. So now you can see that the mean has been calculated and stored in the new array. So let's just cross verify this in the calculator. See, what is the mean? You are adding it column wise. So that means 10 plus 13 plus 6 divided by 3. So what does it give? 10 plus 13 plus 16 divided by 3. It gives 13. So that is the first value which is evaluated. And from the second column we get 11 plus 14 plus 17 divided by 3. So you are getting 14 as the mean of the second column. So what does it mean? If I give axis 0, it is doing calculation row wise. Now the same thing, if I just change the axis to 1, it will calculate the mean row wise. So we will see one of them. Let's say the middle row, 13 plus 14 plus 15 we will do. (13 plus 14 plus 15 divided by 3). So you're getting 14, which is the mean. So when I take the axis as 1, it is calculating the mean row wise. That's the difference. So we can apply, you also try with other functions like let's go for the universal functions like square root. So what does square root do? So as I said, square root, it is going to calculate square root of each and every element. It's a element by element, right? It's a universal function. So you can see what is the square root of 10? 3.16222. So it has calculated square root for each one of them. We can also try logarithm, which is also another universal function. See, the log of every element is calculated and stored in the array. We can also try to find the sinusoidal value. So np.sin. See, the sine value of every element is calculated. So these are universal functions. Mean, after trying mean, let's also try max. So what does this do? This is going to find the maximum value in that row because its axis is 1. See, this is our original array, right? It is calculating the maximum. So the maximum value in row 1 is 12, so that is stored here. Maximum value in second row is 15, so that is stored here. Maximum value here is 18. Similarly, you can also repeat this for minimum. So these are what? Aggregate functions, because I'm considering the set of values there. See, the minimum value in first row is 10. Minimum value in second row is 13. Minimum value in third row is 16. Okay, so suppose I want to write my own function. You can also do that, right? You can also write your own functions. You can also define your own functions and use that as your first argument. So let's just try that also. So let's create a function. So when you create a function, use the keyword def. Let's say the name of the function is f1, and let's give one single argument to this x, give an indentation, and then say give return, right? Because our function has to return a value. That's what I said. Because only if it returns, then that value is going to come here, right? So don't forget this. Please use return statement. And then let's say x by 2. So now your function is defined, and now here what I'm going to do is in the apply along axis, I'm just going to write here f1. Where is the terminal? Yes. So when I say f1, f1 is a function. It will come here. It will take the axis as 1. So it is going to do row wise calculation, and array is a. So upon the array a is going to apply this function f1. Now when I press enter, what has happened? The real array is this, right? So for every element has been divided by 2 here. You can see every element has been divided by 2. Okay, so it's a very simple function. It is very useful function because you can aggregate, you can iterate through your loop and also use functions. You can also use your own functions which are returning some values and still iterate it according to the way you want, column wise or row wise. So try all these examples in your system. And to just quickly revise, in this session we went through how we can iterate iterate an array using for loop, what is the functionality of dot flat, how to iterate through a multidimensional array. We also saw the significance of apply along axis function. So in the next session we will discuss about conditions and Boolean arrays. We will see how we can do shape manipulation of the arrays using the reshape function, ravel function, shape and transpose function. Thank you.